This video describes sizing a linear amplifier driving a linear brushless motor and uses a simple Excel sheet available from the Varedan website. The block diagram here depicts a typical motion control system employing a linear brushless motor. There's a motion controller, a Varedan linear amplifier, and the linear brushless motor and load. The motion controller specifies a position profile and implicitly a velocity profile. It's the velocity profile that we'll use to size the Varedan amplifier. The amplifier accepts a force or current command from the motion controller and then produces the 3 phase currents for the brushless motor. Our goal is to determine the amplifier requirements given the velocity profile, the motor specifications, and the load. For the motor, we need to know the motor force constant, K sub F. This is the force produced at constant velocity when each of the phases is driven with a 1 amp RMS current. The motor phase-to-phase back EMF constant is also needed, and that's K sub E, and that is the peak phase-to-phase voltage when the motor is moving at 1 meter per second. Similarly, we need the phase-to-phase resistance, inductance, and the motor pitch, which is the spacing between north poles or equivalently between south poles in the motor structure. And we need the total moving mass of the system, that in the motor and that outside the motor. With these quantities and the velocity profile, we can solve for the 5 key amplifier requirements: the bipolar amplifier bus voltage, the peak output current, the continuous output current, I continuous. Equivalently, this is sometimes referred to as the average RMS currents. The peak output power dissipated in any one transistor, and then the continuous power dissipation in the heatsink, or equivalently the average power transmitted to the heatsink. Let's do an example. So again, the inputs we need are a velocity profile. So for the spreadsheet, we'll use trapezoidal profiles because they're easy to describe in terms of the corner times and velocities. So in the case of this trapezoidal profile, the inputs would be 0 seconds and 0 meters per second, and then at 50 milliseconds the velocity is 1 meter per second. At 450 milliseconds, again, the velocity is 1 meter per second, and so forth. We assume that this is a periodic motions for the purposes of computing average power dissipation and average currents. And for the motor parameters, we'll take the values listed here. We'll simply input these into the LBM spreadsheet. Here is the LBM spreadsheet available from the Varedan website. The spreadsheet name is LBM followed by the version date. Once it is filled out, you can simply email the completed spreadsheet to sales@varedan.com or other Varedan contact that you might be working with. The spreadsheet is color-coded. Blue indicates design inputs that must be supplied by the user. We fill in the blue cells enclosed in heavy boxes, for example, this heavy box right here. The green indicates outputs, which are the amplifier requirements. So these are the quantities that the spreadsheet computes. First, we enter the motor parameters. These are the force constant, the back EMF constant, the resistance, phase-to-phase resistance, phase-to-phase inductance, the pitch, and the total moving mass. The red flags indicate comments, and we can understand a little bit more about the cell by opening those up, and then we can go back and hide the comments. Okay, so again, as we look at the heavy black boxes, these are quantities that we can supply. For example, the units. We can choose newtons per amp RMS, millinewtons, pounds force, ounce force, and so forth. In our example, we're using SI units. Similarly, we can choose the back EMF units, the mass units, the pitch units. This is meters, and then the mass units. So we input the values. I've already entered those here: 39, 32, 2.7, 0.018 henries, or 18 millihenries, 24 millimeters. We want to be careful with the units, and the moving mass, 24.6 kilograms. Next, we want to input the 9 corner points, the time velocity of the worst case trapezoidal velocity profile. So this is the profile that we think will be taxing to our system. And so those corner times are at 0, 50 milliseconds, 450 milliseconds, half a second, 0.9 second, 0.95, and so forth, up to 1.8 seconds. And we assume, for the sake of this calculation, that motion is periodic. And so the heating of the heat sink and transistors will be computed assuming that that's periodic. Likewise, the velocities of the corner points are 0, 1, 1, 0, 0, minus 1, minus 1. These are units of meter per second, and 0, 0. And likewise here, we can choose different units, and the conversions are automatic and internal. With these inputs, the spreadsheet computes the key amplifier requirements that we transmit to Varedan for selection of an amplifier. And a lot of times when we do a design, we might enter a margin to add so we can allow for errors and so forth. So here we might input 20% for the bipolar amplifier bus voltage. Similarly, for peak power, you might want to allow for some margin there. That's it. Email this completed spreadsheet, and we can work with you to select an amplifier.